chemistry. Nuclear chemistry is the study of chemical and physical properties of elements as influenced by changes in the structure of the atomic nucleus. Who is Marie Curie? Marie Curie is the founder of the field of nuclear chemistry, and she is also the first one to coin the term of radioactivity. She is fascinated by the discovery of Henry Becquerel, which he discovered that an uranium compound that was wrapped in black cloth had been placed near a photographic plate, made an image on the plate. He reasoned that uranium compound emit the radiation of the combination of particles and electromagnetic rays that could pass through the cloth to expose the photographic plate. This phenomenon had been called radioactivity. And the next important person is Ernest Rutherford. Ernest Rutherford had proposed gold foil experiment, and he also named 3 of the most common types of radiation. What is radioactive decay? Radioactive decay is the process of breaking down unstable isotopes into other isotopes. And what is isotopes? Isotopes is the same number of protons but different number of neutrons. Radioactive isotopes is unstable isotopes, and it's been known as parent atom. While for daughter atom is the atom from the decay and may be stable or decay itself. We will proceed with the types of radiation. First, alpha particle. Alpha particle is composed of 2 protons and 2 neutrons that same with the helium nucleus. From the nuclear equation, we can see how radioactive emits an alpha particle. Next is beta particle. Beta particle is eject an electron from the nucleus and have -1 charge. So from the nuclear equation, we can see how radioactive emits beta particle. And the last one is the gamma ray radiation. Gamma ray radiation is energy that form of electromagnetic radiation. From this picture, we can see the types of electromagnetic radiation, which one of the types is gamma ray. And from this nuclear equation, we can see how radioactive emit the gamma ray. And this is how gamma ray radiation is being emitted.
Next, I'm going to explain to you about nuclear transmutation. Nuclear transmutation is the conversion of one nuclide into another. In other words, atoms of one element can be changed into atoms of another element by transmutation. It can occur by the radioactive decay of a nucleus or the reaction of a nucleus with another particle, which is nuclear fusion and nuclear fission. For your guidance, the first man-made nucleus was produced by Ernest Rutherford in 1919 by a transmutation reaction. Rutherford explained that when nitrogen-14 bombarded with a high-speed alpha particle from a natural radioactive isotope of radium, it produced a different nuclide and a proton was ejected from the reaction. A few years later, the product nucleus was identified as oxygen-17 by Patrick Blackett. Nuclear transmutation are commonly represented by listing, in order, the target nucleus, the bombarding particles, the ejected particles, and the product nucleus. If you look at this periodic table, there are chemical elements with atomic numbers greater than 92, which we call as transuranium elements. None of these elements is stable, and each of them decays radioactively into other elements. Uranium is the biggest naturally occurring atom on Earth. To make a new element, uranium-238 was bombarded with another particle and produced neptunium-239. Everything larger than atomic number 92 is man-made or synthetic elements that have gone through the transmutation processes.
Hi everyone, so now I am going to talk about nuclear fusion. So in this part, I will explain a bit about what is the nuclear fusion itself, nuclear fusion in the sun, how to make fusion, and applications of nuclear fusion on Earth. So what is nuclear fusion? Nuclear fusion is a nuclear process where energy is produced by smashing together light atoms. It is the precipitation of fission where heavy isotopes are split apart. Fusion is a process by which the sun and other stars generate light and heat. Einstein's equation says in part that mass energy can be converted into each other. Explains why this process occurs. Next, this is the steps of the nuclear fusion in the sun. So first, two protons within the sun fuse, forming a positron and neutrino, as known as deuterium. Secondly, a third proton collides with the formed deuterium, resulting in the formation of electronucleus and a gamma ray. These rays are released as sunlight. So third, two helium-3 nuclei collide, creating a helium-4 nucleus plus 2 extra protons that escape as 2 hydrogen. So as you can see on the diagram, it explains about the nuclear fusion in the sun. And this is the step on how to make fusion by replicating the conditions in the core of the sun. So first, create plasma. Plasma is one of the 4 states of the matter. In lab, scientists superheat hydrogen gas to create energized plasma. Second, apply pressure which keep the plasma bottled up and the nuclei colliding with each other. This reaction powering the sun relies on gravity for this confining force. Powerful magnetic fields is used to confine the plasma in Earth. So last, repeat the process. The reaction is continuous in the sun. Even though not every collision creates fusion, the ones that do produce enough energy to keep it burning. Scientists hope to create a continuous reaction inside a special machine called a tokamak. And this is the applications of nuclear fusion on Earth. So first, fusion reactor, also known as fusion power plant or thermonuclear reactor. It is a device to produce electrical power from the energy released in a nuclear fusion reaction. If fusion energy generation could be replicated in a controlled manner on Earth, it might very well provide a safe, clean and inexhaustible source of energy. Next is thermonuclear weapon. Hydrogen bombs is one of the weapons used in World War II. They are usually defined as nuclear weapons in which at least a portion of the energy is released by nuclear fusion. That is the comparison of hydrogen bomb and atomic bomb. Okay, thank you.
Nuclear fission is a process by which the nucleus of an atom is split into two or more smaller nuclei, known as fission products. The fission of heavy elements in an exothermic reaction and huge amount of energy are released in the process. Nuclear fission occurs with heavier elements where the electromagnetic force pushing the nucleus apart dominates the strong nuclear force holding it together. In 1938, Lise Meitner and Otto Hahn was collaborators and pioneers in the field of nuclear fissions. They had discovering several new isotopes and exploring neutron bombardment of uranium. In order to initiate fission, a high-energy neutron is directed toward a nucleus, such as uranium-235. This causes the nucleus to become uranium-236, which is violently unstable. The entire nucleus is split into large fragments, chromium and barium, that we call daughter nuclei. In addition to the daughter products, 2 or 3 neutrons also explode out of the fission reaction, and this can collide with other uranium nuclei to cause future fission reaction. It is known as a chain reaction. We can see how the chain reaction works in the next slide. Okay, this is example how the chain reaction happens. There are 2 types of nuclear fission. First type is subcritical mass. That means the chain reaction has stopped because the neutrons are loose from the mass without causing fission. The second is supercritical mass. That chain reaction is accelerated and process continues. For a chain reaction to occur, enough uranium must be present in the sample without causing fission. Otherwise, many of the neutrons will escape from the sample, thus the chain reaction will not occur.
Comparison of chemical reaction and nuclear reaction. A chemical reaction rearranges the constituent atoms of the reactants to create different substances as products. It involves electrons and does not involve changes in the nuclei. While the nuclear reactions involve a change in an atom's nucleus that usually producing a different element. The composition of the nucleus have nothing to do with the electrons. In chemical reaction, different isotopes of an element normally behave similarly, while in nuclear reactions, elements of isotopes of the same elements are converted from one to another. Nuclear structure of atomic species remains unchanged, and reactants and products have equal mass in chemical reactions. But in nuclear reaction, the nuclear structure of atomic species changes, and there is mass change. Chemical reactions are accompanied by absorption or release of relatively small amounts of energy. Nuclear reactions are accompanied by absorption or release of tremendous amounts of energy.
2. The SAR bomb. Of all the nuclear bombs on this list, none quite meet the size and scale of the SAR bomb. That's because it holds the record for being both the largest nuclear weapon ever set off and the most powerful human-made explosion ever recorded, thanks to its yield of over 50 megatons. Meant to be a demonstration of Soviet strength, it was dropped on October 17, 1961, over the northern Russian test site in Mitsushka Bay in a modified Tu-95 bomb carrier aircraft. Giving off a flare that was observed as far away as Norway, Greenland, and Alaska, its shockwave circled the globe 3 times, and it was so strong that it destroyed every building located 55 kilometers around the blast site, while completely shattering windows thousands of kilometers away. Unsurprisingly, this upset a number of non-Soviet countries who were affected by the blast. More specifically, the countries in question were the Scandinavian nations of Finland, Sweden, Norway, and Denmark, who condemned the testing as an act of aggression.
Last but not least, the rates of reaction in chemical reaction are influenced by temperature, pressure, concentration, and catalyst. But the rates of reaction in nuclear reaction normally are not affected by temperature, pressure, and catalyst.